So it is a tech stack that, one, automates a lot of our processes. It is very scalable in terms of increasing the amount of compute power, the amount of storage. Webhooks work hand in hand with the Apache Airflow for workflow orchestration. So our APIs, or rather our webhooks, are going to notify our system that we have a new record. It is only going to execute tasks when a new record is submitted. I look forward to becoming a solutions architect.
We're here to amplify African tech stories and elevate technical brilliance. This is the Geo Habari podcast with Yariwo Kitiyo. Hi guys, welcome to another episode of the Geo Habari podcast. This is the Tech Stacks and Architectures series. We have intentionally curated this series to take us on a learning journey to understand the individual building blocks of powerful tech stacks that make geospatial technology tick. From programming languages, databases, softwares, cloud infrastructure, and so much more, we feature individuals sitting at the very core of developing these systems end to end. Welcome to the Tech Stack series. Hi everyone. So welcome to episode 1 of the Tech Stack series. Episode 1 is specifically going to focus on data pipelines, and our guest today is called Allan Mogley. Allan works as a GIS Systems Developer at Planate Management Group. What Allan does is designing, building, and maintaining automated GIS data pipelines. On this specific episode, we're going to go on a behind-the-scenes journey where he's going to walk us through the world of data pipelines, building data pipelines, what's a good data pipeline, and the tech stack that he uses to build these powerful pipelines. And so without further ado, allow me to welcome Allan onto the podcast and officially onto the Tech Stack series. Hi, Allan.
Hi, everyone. Hi, Ario. This is Allan, and Allan is a software engineer. I specialize in data, and I have a background in geospatial engineering. I'm currently a GIS developer, and I'm the kind of guy that creates maps, applications like Google Maps, and everything beautiful that you see on your phone, telling where to go in terms of directions. Thank you very much, Ario, for having me.
Thank you, Allan. And I love that you've said everything beautiful. You mentioned you're a GIS developer. For a start, maybe, Allan, what's your background? How did you get introduced into GIS?
Well, I enrolled into JKUAT University to study geospatial engineering. And right from the first day, I fell in love with this profession. And my first experience was working as an assistant geospatial engineer at a road construction authorities called Kenya Rural Roads Authority. I later on moved to become a research assistant at a research program within my department, as it's called the Drone Research Group. And I was majorly tasked with creating outputs from drone and satellite data, for example, outputs that can be used and applied in agriculture and infrastructure. I later moved to become a data scientist intern at Zido Development, a software company based in India, where I majorly now focused in data science and AI and machine learning. I later on joined the Planate Management Group as a GIS engineer, where I was majorly tasked with creating automated systems that handle the GIS data within the various departments of the company. Now I was promoted within the same organization to become a GIS developer, majorly focusing on creating automated data pipelines and integrating of AI and machine learning models within the GIS workflows. I was very, very interested in software development. So I started learning programming at my second year of study. And I have been learning ever since within the software development field, and equipping myself with a lot of knowledge, as well as partaking on different projects within the same field.
And you've mentioned very interesting and exciting concepts which the series is pegged on. You've mentioned software development, automation, and then machine learning and AI models. So I think for a start, with reference to this series, we call the series Tech Stacks and Architectures, and understanding the roles behind these stacks. And I think from your own definition, how would you define a tech stack based on your background and what you do in the pipeline world or in the GIS development or software development world? What would be your own understanding of what a stack is?
From my experience and background, a tech stack is basically the latest system and tools that are used to create the applications that we interact with every single day. It is very easy to like an application like Google Maps or rather Apple Maps. It is very interesting to use these platforms without actually realizing the tools that are used to build these applications. Beautiful maps that we use on our phones are very interesting, but the technology kind of evolves over time. And the modern tech stack involves the use of satellite data, the use of drone data, the use of high precision GPS and GNSS instruments to acquire information about the gadgets that we use. So a modern tech stack is something that is constantly evolving, is something that is constantly changing. And every now and then, there is a lot of data streaming in, and we have to use tools that will scale up and down depending on how much data is coming in. And this tech stack basically has to incorporate automation. So it's going to handle this data automatically itself. It is going to be very scalable itself. It is going to increase the amount of storage. It's going to increase the amount of computing power, depending on the amount of data that is streaming in. It is also going to be something very efficient in terms of saving on cost, in terms of saving on time. An example, we get to use Google Maps. I don't think there is someone that pays to use Google Maps, except for those companies that want to use Google Maps for commercial purposes, for example, like advertising and so on. A modern tech stack is also something that enhances collaboration. We are people in the geospatial field, but our products are being used by people in advertising. Our products are being used by people in architecture and planning. Our products are being used in people in environment and so on. So it is a tech stack that, one, automates a lot of our processes, is very scalable in terms of increasing the amount of compute power, the amount of storage. It is something that is very sufficient, and it is something that collaborates with people with different fields.
Oh, wow. I love that, especially the part where you said it's something that is scalable and it should also evolve with time and catalyze collaboration. That is very insightful. And so I want us to bring this discussion home to the GIS world, right? And moving away from the idea of GIS centrally being pegged on desktop and so not being able to, the things you've talked about, the scalability, collaboration. And as technology is changing, we are seeing a lot of that changing as well from a GIS perspective, where we are moving from not necessarily desktop, but also cloud, and seeing how that can be upscaled and stabilized to serve users and collaborate. And so from your perspective, when you're talking about GIS data pipelines, you initially mentioned you build data pipelines around and also automation. When you're building these pipelines, what does that look like? What are the tools that go behind it? And the reason I'm asking that is because I saw on your LinkedIn is you mentioned Lambda and Airflow, and I was curious on how those fit in a geospatial tech stack or a workflow when it comes to pipelines. School us, educate us on what that looks like from a GIS perspective when you're building pipelines and automating them.
Very true. Now, this field of creating automated pipelines is actually called data engineering. And it is a field that basically you create components, or rather different sections or checkpoints that move data between different sources and applications. And I use a number of tools. There are probably 100+ tools that can be used, but there are specific tools that are actually preferred for these different tasks. Now, I'm going to start from the very, very basic tools, even from the operating system that I use. One tool that I use is called the Linux operating system. A lot of my development work is carried out on Linux. On my laptop, I have Windows installed, but I have managed to install Linux as well using a platform called WSL. It's called a Windows subsystem for Linux. So if there is anyone that is wanting to get started on Linux, you don't have to remove or rather to uninstall Windows on your laptop. You can run Linux directly on your laptop. And Linux is very important because all the terminologies, or rather all the technologies of the cloud and data and everything else run with the basis, or rather the system. The underlying structure is usually Linux operating system. So an understanding of how Linux works is very, very, very key in creating and deploying systems. And once you have Linux installed on your computer and you are very good to go with Linux, the next concept that I use, or other tools that I use, is called containerization and networking. And here I'm using tools like Docker and Podman. Now, what containerization does is basically takes your application, or rather your piece of code, and creates an environment that can be replicated in someone else operating system, or rather in someone else's system computer. So the best explanation of this is when you submit the kind of work to a client, and then you're like, this application is not running on my end, and then like you tell them it works on my computer. So what containerization does, it creates a common environment that you can use in your own computer. Once you send that container, or rather the image, to your client, they use the same image to run the same system. So it basically solves the problem of environment within your system. The next concept that is very key in this modern data stack are the programming, or rather the scripting languages. I code in Python. I'm very good in Python. And then I'm also good in Bash scripting. Bash scripting is kind of like the programming language that is used in Linux operating system. So it basically tells the Linux operating system, perform this task, and so on and so on. It is also very key to understand and master SQL, structured query language, which is basically like the kind of language that is used to talk to databases. And also JavaScript might also be important for someone trying to get into this field. It is a language that is very, very key when you're creating front-end systems, when you're creating APIs to connect the front end of your application to the backend, which are the databases. Now, after getting into Linux and containerization, and you have their programming languages in check, there is something called workflow orchestration. Now, you have written your scripts in whatever language that you are doing. Now you need to provide rather a flow map, or rather an orchestration, or rather an architecture of how this system is going to run from point A all the way to point Z. So it basically gives instruction that you're going to execute this task. Then after this task, you're going to execute task number 2. After task number 2, you'd execute 3, and so on and so on. And one of my best tool I usually use is called Apache Airflow. Apache Airflow is basically a tool that you configure, and you tell your system when new data comes in, when somebody submits a report, when somebody submits data, I want you to perform a certain kind of processing. First, I want you to select this kind of data set. Then after you select this data set, I want you to run this algorithm on this data set. After you perform this step 2, I want you to apply this machine learning model to this data set. After you apply this model, I want you to upload this data to this database, or to this output, or rather to this server. So Apache Airflow is basically to orchestrate, or rather to tell your system how you're going to connect this data from its source all the way to the destination. So it's going to go to point 1, point 2, point 3, point 4, the flow that this data is going to follow. It is also very important to understand webhooks. So webhooks work hand in hand with the Apache Airflow for workflow orchestration, because within Apache Airflow, you get to say that I want you to run this task every single day. So on this day, you run it at these specific times. The following day, you run it at this specific time, or rather you can configure your system to run these tasks every 5 minutes, every 10 minutes, and so on. But when you're working with things called webhooks and events, you're basically connecting your application A to application B, for example, Google Maps, such that if somebody is collecting data in the field, or rather you're using ArcGIS Survey 123, if somebody is collecting data in the field about something, schools and so on, if he submits the data, this data is going to come into our database. So our APIs, or rather our webhooks, are going to notify our system that we have a new record. So this system is going to take that new record and take it through the processing pipeline. So the system is not going to run, or rather to query the database full time. It is only going to execute tasks when a new record is submitted. Apart from that, we also have real-time data streaming systems, and my favorite is called Apache Kafka. And a great example is when you want to go from point A, you want to go from Nairobi to around Westlands, the town and so on, and the environments, you order an Uber. And then one interesting thing is that the Uber accepts your request, and you can clearly see that icon of that car, the Uber is coming as is coming towards your location in real time. So one of the underlying tools that is enabling this real-time view of the Uber driver coming to your location is Apache Kafka. So it basically connects your location to the location of the driver in real time, and then it constantly updates the location of the driver as the driver is coming towards your location. It is also important to understand the cloud computing platform such as the Microsoft Azure, AWS, and Google Cloud Platform, because nowadays we are moving away from the traditional having a server within an office to the cloud platforms. So we are creating our applications and then deploying them to the cloud. So they are constantly running in the clouds. And cloud platforms actually save a lot of cost when you're trying to set up your system within an organization, because it works on the principle that you pay only for the kind of services that you use, and you only pay for the amount of time that your server is running. Within the cloud computing platforms, there are also some tools that are very, very key to understand. There is serverless functions, or rather serverless applications. So these are basically applications that do not require coding or rather programming or anything. They are basically like a graphical user interface. You only go there and you select. You basically tell it you want to connect application A to application B. So you connect the two applications and you're saying that if a specific event occurs, I want you to execute this script of code. If data is submitted to this folder, or whether data is submitted to this link, I want you to take that data and take it through the data processing pipeline. And lastly, storages. The data can be stored in databases, data can be stored in the data warehouse and so on. But the initial storage of data is something within the cloud environment. We have an Azure data lake if you're dealing with the Microsoft Azure. And then we have AWS S3 buckets if you're within AWS cloud platform. So if somebody is, for example, if the data that is being collected by drones or rather by satellites, if it is streamed back to the earth, this data is taken and it is stored in something is called an S3 bucket. So it is like a storage that has very, 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 very high storage capacity. So it almost never goes out of storage. So the storage of this data set is in an S3 bucket or something like an Azure data lake. So if you're developing your system, it will be worth considering of where you're going to store these data sets. So a Linux operating system, understanding of containerization and networking, specifically Docker, the programming languages including Python and SQL and Bash scripting. We also have Apache Airflow. I also work with APIs, Apache Kafka, AWS Cloud Computing Platform, Microsoft Azure as my tech stack.
I'm curious to know, as you're building this pipeline, I like how you've mentioned all the tools you use and how they come together. What defines a good data pipeline for you as a data engineer?
A good data pipeline, it has to be automated. It is a data pipeline. It is moving data from point A to point B to point C. So the automation of this data pipeline is very key. So it is automated. And because you're creating a system that has to handle both small volumes of data and large volumes of data, it has to be scalable. For example, if you're looking at satellite images, you have this data that is very, very, very huge. It is usually probably terabyte for a single area. It can be a huge amount of data set. So we are making sure that this data pipeline can be able to handle the on-stream or rather the coming of that imagery to be able to be stored in an S3 bucket or any storage that you get to choose. So my data pipeline has to be an automated. I don't have to be physically pressing my computer to execute the tasks. It has to be scalable. If small volumes of data is coming in, it uses small compute power. If I'm having large volumes of data coming in, it has to automatically scale on itself to accommodate the high processing power required to process this data. It is also efficient because, for example, if I have manually processing data and it takes me 30 days to do that processing, I would create a pipeline that will basically take at max 10 seconds to process the same data. So a good data pipeline from me is very efficient in terms of cost savings and also in terms of time savings. So I want to cut off something that will take 30 days into 10 minutes max to process. And a good data pipeline has to be something that can easily be integrated into other platforms. An example would be something like ArcGIS platforms. Like if we have survey 1 to 3, which is used to collect data in the field, I want once this data has been collected in the field and submitted to a database, my data pipeline should automatically select that data and take it through the processing pipeline, apply any transformations, and then load this data to the next level. This data should finally be available to people who are not even within the GIS department. You see, this data can be very beneficial within the GIS department, but once somebody from architecture tries to use it, it is in a format that they cannot open in their computers. These people use some softwares for 3D modeling that require specific formats of data. So my pipeline should be able to collaborate, or rather to integrate, or rather to save in a format that can be used by people within the different departments. So I mostly work with ArcGIS suite of products. So I'm using the platform using their APIs to connect our internal, or rather our custom systems. I also use a Microsoft Azure as our cloud provider, where my scripts are basically running in that cloud. If there are very huge, there's a requirement for the storage of data, I will usually store it in blob storage within Microsoft Azure storage. And I almost always containerize my application. So all my applications, I'm developing them within a Docker environment. And once in a while, I use serverless tools like Azure Functions, which basically is my operations in connecting System A and System B. So that will be a good modern, or rather an efficient GIS data pipeline in my line of work.
I'm trying to connect the tooling you've talked about and what the tooling serves to the end user, what's happening in the back end with what that use case is. We just create like a complete story or a complete picture. What would this use case be like?
Mm-hmm.
The need that the user requires that is taking us through this process, maybe for the audience to just understand, for those of us who are new to this concept.
Well, if, for example, in an infrastructure development project, an architect wants contours and the XY location of buildings only. A project manager will require an Excel sheet that will have the location, but not the XY location as in latitude and longitude. They want the name of the area. For example, they will want the name school, for example, Nairobi. They want the name Nairobi to be as an identifier of the location, not the latitude and longitude, because they are not going to plot these coordinates. So for an architect, I will create a script that will extract the data from ArcGIS online databases, and then it is going to process this data to generate contours. It is going to process this data to generate latitude and longitudes. And then from the same latitude and longitude, it's going to process this data to generate, to transform these coordinates into X and Y as in meters. I don't know if you understand that, because there are some geographical transformations that are usually carried from within the latitude and longitude to nothings and distance. So it is going to be a script that generates contours, a script that generates the horizontal locations of these features, a script that is going to generate the descriptions of these features, and then it is going to upload this data into a common sharing platform. So within our company, we are using Microsoft SharePoint. So it is going to post into a directory that this architect has access to. So whenever someone in the field collects data about school A, that data is going to be taken through the processing pipeline and then pasted into a directory called folder A. If the same person goes to another school and collects data, once he submits it, that data goes through the processing pipeline and saves it into a different folder B. So these data sets are going to be organized into the different folders. From the same data set, this project manager requires an Excel sheet that contains the school name, the location of the name, as in whether it is in Nairobi or Mombasa or in Kisumu. And it also requires the number of rooms within that school, the number of features, the features within that school. So this same data set, you have to write a script that is going to select the required columns. You're going to write a script that is basically, or rather generate a geocode, or rather compute the geocode, because if you're having latitude and longitude, you can basically try to extract the name of that approximate location. So a project manager is not going to look at latitude and longitude, it's going to look at the name of that. So it is going to extract those data and then paste them into an Excel sheet of that specific project manager. So this architect is not going to see the data of this project manager. This project manager is not going to see the data of this architect, or rather you can implement authorization of how they can collaborate with one another. So different departments require GIS data, but if you're going to manually click and select the different and then post it into this platform, rather it will be better if you just create a system that automatically knows this architect, I'm giving him this project manager, I'm giving him this business development department, I'm giving him this, and so on. So that is basically how the data pipeline works and connects the different people within different organizations, or rather departments.
As we wind up, I'm wondering, what do you like about your role as a data engineer? What excites you about that particular role?
Well, first of all, it is very interesting that nearly every project is different from what I did before. Some may look very similar, but once you go through the requirements and the deliverables, you find a concept that you had not done before and that you need to learn about. So it is very interesting to learn new things within your field of study. I'm also very interested with satellite and drone data. I have worked with this data, and it is very, very interesting to look at the areas, especially the areas of the regions that you know of. If you could have a data of your own hometown, of your own area where you come from, you'll be very interested to see how this geospatial data is capturing data about our environment, about our infrastructure, and showing how a specific area has been developing over time. So the things that interesting is the technology, the software engineering part, where I'm connecting different departments to the GIS and creating an outreach that basically enhances the operations of the company.
Do you see your role evolving over time? Do you see yourself moving from maybe data engineering to something else?
Well, definitely. I am constantly learning and pursuing more knowledge in this field. I started as a data analyst, basically just analyzing data in Excel files, analyzing data in databases. And then I later on moved to become a data scientist. Now, in this role, I majorly focused on building algorithms, AI and machine learning algorithms that process data, that try to make predictions, that experiment data, that try to classify data, and so on. After being in this data science field for a while, I started to move upwards towards the data engineering field, because you see, when you are a data scientist, you will write scripts that basically analyze and process the data. But I saw a gap between integrating whatever you have within your environment to whatever that can be attached to system A, system B, system C. So data engineering basically takes what a data scientist had done and trying to create a system that automates whatever these algorithms do, and creating a system that basically scales on itself, a system that basically integrate with other applications and services. From the data engineering field, I see myself moving towards upwards the architecture field. And an architect is basically this person that cuts across the board with data analysis, science, data engineering, and so on, with a great understanding of business operations. Because being a very technical person is one thing, and being the kind of person that creates system that generate revenue directly to the company is very key. So an understanding of business operations the technical GIS operations, an understanding of cloud computing operations, and almost immediately figuring out the best practices to be applied in a specific problem is what a data architect, or rather a solutions architect, be. So as I am in this field, I look forward to moving up to becoming an architect, a solutions architect.
That was very insightful, Alan, and thank you for sharing that. And I can't wait to see how your career trajectory evolves over time. I think we've come to the end of the recording. Any advice, parting shots that you'd give to the audience?
As you've heard, I have been through a number of roles. I've been through a number of activities and so on, but it has not been easy. I've always been the kind of person that is constantly learning, that is constantly exploring, and I do make a lot of mistakes. And it is from these mistakes that I learn a lot. Maybe a very, very, very short advice, or rather to someone that wants to venture into this field, I will tell them, just do it. Don't wait for anything. Don't try to do a lot of research and that. Just start by doing something. You will figure it out later. Thank you.
Thank you so much, guys. That was Alan's episode on tech stacks and architectures, and we've been taken through the world of data pipelines and what that looks like and the tools he uses every single day in building that. And I like that his scenarios have been very practical with examples on how he'd approach a particular problem. And he also defined to us what a good data pipeline is. And so that's it on today's episode of the Tech Stack series, with specifics on data pipelines and what that looks like in the world of GIS.